How's it going, guys? So throughout my Facebook market and Craigslist shopping, I've come across a lot of Kobalt 24 volt tools. They seem to be less popular than like the DeWalt and the Milwaukee for whatever reason, but they do have 6 cells in series. They use pretty good quality cells and pretty good quality motors in their tools. So I've been collecting whenever I find good deals, and what I ended up with was a lot of extra charging. And I thought, why not make a DC little mini power station out of one of these? So took the screws off the bottom. I think that was T10 security Torx, and although you can fudge that by just using a small straight blade standard screwdriver, sometimes you can just take them out with those if you don't have that security bit. And then I took all the charging guts out of there, and all I had left was the positive and negative pin inside. So I just soldered the negatives and the positives to both of these in parallel. Everything's in parallel. In this case, I have a little USB adapter, which inside looks like that. It's got the threads on it, and you can choose like lots of different configurations. These things are all over the internet and Amazon and Temu and so on. You just have your positive and negative. And in this case, you got a little power switch. You got a voltmeter in the middle. You can get green, red, or blue on that. I love the red ones. And you got your PD. In this case, is a PD 55, so this one can actually put out 20 volts in case you need to charge something heavy duty. In this case, I chose the red light with a pair of PD 30s on it. I really like the red, kind of like unobtrusive, but you can still see at night to find those ports really easily. And you have that little mini power switch there, which if you have this thing off, it does actually still draw like the tiniest bit of power. But I've calculated that it would kill a battery in like 6 months if you just had a battery sitting in this cradle. So when it's on, your overhead power is something along the lines of like 0.5 watts. So that's pretty good. If you're charging a cell phone at 8 watts and your overhead power is only 0.5, then you're going to get the full amount of charges out of your battery that you should get, instead of we're ending up with half as many charges. So this is a good example where the Ryobi version, it's got this inverter, this modified sine wave inverter for AC power. And when you turn this thing on, you're powering up the AC and the DC both. There's no way to pick one or the other. So you're going to pay 3 watts of overhead power, which is not terrible, but it's, reducing your efficiency of your charging. And also you have your DC to DC conversion going on, which is also a loss of efficiency on top of that, because you're going to be going from 18 volts down to 5 volts, and then from 5 volts down to 4 volts inside the phone, and every conversion is a loss. So trying to minimize those losses, you just want to go direct and not have powering up stuff you're never going to use. I almost never would want to use this little AC port. Also, because it's modified sine wave. This guy, for example, is a 300 watt pure sine wave, and it's got the same problem. If you turn it on, you're going to get your DC port and your AC ports both powered up, and you end up with 7 watts of standby power. So if you're just charging phones, you're only going to get half as many charges out of a battery as you would on this guy over here, because there's no overhead power. I do love this little thing though for situations where you need AC power, like if you want to run a little tiny heater, like a little hot air heater. I use those for heat shrinking stuff, things like that. Maybe like a soldering iron or Dremel or whatever tools you might have. This is really nice in terms of portability, but as far as being like great for charging stuff, not so much. Even though you have a PD30 port, you're still going to pay 25% tax for no particular reason, because of that extra AC power overhead that you can't switch off. Here's something that kind of is inspiring. This Snow Joe 24 volt. It's actually got 2 rows of 4 amp hour 21700s. So you get it's a nominal voltage is 21.6 on this and on any of these 24 volt tools. And you're getting that 8 amp hours because you got 2 rows of 4. But what they don't really advertise or talk about, just throw this in here, is a PD 100 in-out port. So you can charge this battery from a PD port. It doesn't have to be a 100. You could charge from a 30 or whatever you have, and it will take 20 volts if it can. In this case, these are actually limited to 12 volt output. So if you put something like this inside, which this one is the car plug style, something like this actually will put out almost 100 watts. It's supposed to be 100, but it's really, these are actual measurements I've got. They're limited to 80 and 90. But this thing will take 12 volts, 24 volts, 18 volts, even up to 30 volts of an input, and give you PD 100 output, which is 20 volts times 5 amps. In this case, I get 20 volts times 4 amps right here and 4.5 here, which is fine. It's close enough for me. And I add this little piece of this is a little tip here. I add a little piece of duct tape right here. This is clean release duct tape because it keeps it really, really firm when you plug into your outlet. So that way this connection here is really solid. You don't want this thing to heat up because it's critical, to have that really good. This is the positive prong. So you don't want to get like super hot, especially if you're running a PD 100 on the other side of a 12 volt input, then you're going to have a lot more current flowing through. It's going to get a lot hotter. And yes, this is $6. The thing was like $18 on Temu, and you get a promotion, it was like $6. So that's pretty awesome. And of course, you could put a cigarette plug input on that. It's the same exact size hole. This is a 1 1/8 hole that I drilled with a hole saw. So I could have chose to put that on. That way I'd have the ability to choose different options, different configurations on there. Well, like I said, I could have put this guy here and got the PD55 with the voltmeter and all that. So there's lots of different ways you could do it. Now I also have the XT60 input, which is directly powered by the battery. So that means this can be an input or an output. If you want to charge this battery, you need a DC to DC converter. And I do use that to charge these because I have a 24 volt battery in the basement. It's a lithium iron phosphate, and I run a big beefy power wire upstairs and hook it up to a DC to DC buck boost converter. And then I can actually dial in the exact voltage and the exact current that I want to charge this battery. The conversion is about 88% efficient. Here's an example of a buck boost DC to DC charger. So you can take an input of, I think, anywhere from 5 volts up to like 30 something volts. I have to double check on that, what the high voltage is. And then you can actually dial in a custom voltage that you want on the outside. And that way you could charge any battery from any battery, basically, which comes in handy. Say you wanted to charge this guy. This is a lithium iron phosphate. I might charge that at, say, 14 volts. So I could use, if I needed for some reason this charge specifically, I could use any kind of voltage input to get that done with one of these adapters. But what I use this most commonly for is to charge from a 24 volt lithium iron phosphate and charge up my Ryobi batteries, Milwaukee batteries, DeWalt batteries, and 24 volt batteries also. I have a couple of them, and one of them is preset for 18 volt batteries at like 20.5 volts. I don't go all the way to 21. And then I have some that are preset for 24 volt batteries as well. Again, this is a nominal voltage of 21.6, I believe. So when you see, for example, that this has 48 watt hours of capacity, it's actually not true. It's actually 21.6 times 2. A lot of battery companies do that just to keep things simple. They just multiply the max voltage or the approximate voltage times the amp hours and call that good. But some companies are more accurate about it than others, but it gets you in the ballpark. Here I've got the DJI Avata 2 charging cradle, and this one is a USB-C input. The battery itself is 16 volts. That's what it really needs inside there. And I think that may not be the nominal voltage, but that's the charging voltage, I believe. So what you really would want in this case is you'd want a PD that could put out 20 volts. And in that case, you maybe want something more like that. The 55 watt that can actually do 20 volts rather than something like this, which is limited to 12 volts at PD 30. I think if you use a PD 35, you get 20 volts. So, but the thing is, you don't need to charge it. This is a 60 watt cradle. So if you run 20 volts times 3 amps, it'll take pretty much all that power and dump it into this battery. But you may not be in a rush. If you're out in the field and you're trying to charge your battery right on the spot, then sure, you want the maximum output. But if you are charging overnight, you just throw all 3 batteries in there and you can charge at 30 watts, that's fine. Or 35 watts is probably my favorite for that because it puts out a 20 volt output, which is a close match to what this thing needs, so you don't have as much loss in the conversion. And again, if you had the cigarette output, you could choose a PD35. I have some like this that are 35 watt output that I could choose specifically for that purpose. You have the ability to customize that with this. And if you're flying drones, you've got goggles and controllers and all kinds of different batteries and things that need different outputs, right? That can, some of them want 5 volts, some of them will take 9 volts and so on. So you can customize that. You could probably put 2 ports. You could drill 2 holes, one on each side, and have a bunch of more PD ports on the output, and these batteries would have no problem putting out a pretty significant amount of wattage. I think that you might want to say, these are high drain, so in theory they should be able to put out quite a lot. And you're not going to have a huge loss of capacity by doing that. Although if you're going to use a lot of power out, then you're going to want to maybe use a bigger battery than a 2 amp hour. So another option you can use with this XT60, because you have direct tap into those 24 volt terminals, really 21.6, is something like this. So you can get like a 24 volt to 12 volt converter. This one happens to be a 12 to 19, but it just makes an example. You actually do have a range of inputs on these usually, and they're usually specifically buck or boost, and they are pretty reasonably efficient. I've heard as much as 95% efficient, although I haven't tested this particular one. So you could go from 24 volts down to 12 volts if you have a 12 volt need, and you could easily do a 12 volt 10 amp output, which is pretty standard, 120 watts. Here are some other examples where you have the Hart. This is a really 18 volt nominal 5 series, and you've got a regular USB output here, and you've got a 12 volt output. This is for the heated jacket. It's very compact, it's relatively cheap. That's pretty cool. But you can't really do a whole lot with this compared to what you can do with this, especially with the customization to choose the ones that you need. And here's the Hercules. That's got a pair of USB outputs. That's pretty cool. I've got some Hercules tools. I was impressed by the quality of their brushless impact driver, for example. I've got the heat gun. I love it. I don't have a lot of batteries for these ones. And this is for Makita. I got this off of Temu really cheap, and it didn't work quite right. I wasn't getting, so there's something wrong with the PD output on it, but the USB output works fine. So just some examples of other ways of doing a direct DC to DC with a very low power overhead. This one is really cool. This little doodad here takes a USB-C input and it calls for 20 volts. So if you have a PD100 port that can deliver 20 volts times 5 amps, this thing will call for that. So basically what you would do is you'd use, if you have a cable that's actually capable to carry that 100 watts, and you have to be careful because some of them will say 100 watts on it, but actually don't. They can be limited to 60. Then you can transmit power from, say, a 24 or a 12 volt source through this thing to a PD100, through this cable to here. Now you've got 100 watts, and you have a DC barrel that you can match up with, say, a laptop, for example. So that way you have DC to DC direct power on your laptop without going through an inverter and an AC to DC converter and all that stuff. And this thing will provide enough power for basic use. I'm able to use this on my MSI gaming laptop to watch movies. And if you're running the computer in the background or something, it's just sitting there idling 8 or 9 watts. No big deal. And even if you're watching a 4K movie with an X265 decoder, it still has no problem. With 100 watts is enough to get that job done. But if you're charging the battery in the laptop, or you're actually running like a high-powered gaming GPU, then this isn't probably going to be enough, and you're going to have to use the big giant power brick thing. These I've seen in standard size, like a 5.5 by 2.1 millimeter is a standard DC barrel size. This one's a little bigger because this is designed, this one says it's 4 HP. They also have them for Dell. It does have a little bit of a power consumption of its own, in this case 20 milliamps, not that bad. There's a little tiny light that lights up when you do that. But I've seen those on Amazon and seen them on Temu. They're hit or miss in terms of availability, but if you can find one that matches the DC size of your laptop, that's a pretty cool thing to have. Another useful thing with these little DC power station might be like a small heater like this. This is a 5 volt DC heater. It's a fabric style, so you can slip this into a jacket or your pants, or who knows, wherever you need it, on a seat, or even for a pet or something like that, or maybe like outside to keep a cat water bowl from freezing, whatever, a bird feeder or something like that. So there's some uses for that for sure. One thing I wanted to mention was that if you're dealing with something like this is 10 cells in series, so that's a nominal voltage of 36. And if you wanted to convert from 36 volts down to, say, 5 volts, that conversion is such a big difference in voltage that every time I've ever bought a device to do that, I've measured something like 70% efficiency in that conversion process. So that's one reason why you might rather use something like an 18 or 24 volt adapter to get that job done, rather than a 36 or even like a 51, like the Ego. I think it's like 51 volt nominal, something like that, to do that conversion. But some of these charging cradles will have USB ports on them, and these charging cradles are DC. So the power brick is external. So if you have an input, a DC input here, you can actually charge your Ryobi batteries, or vice versa. You can tap into those to that 36 volt terminal using these cradles as well. So that's pretty handy that they give you that. Some of the new charging units don't have the combined AC DC built in inside. For example, like this. This thing would have, you know, AC to DC conversion inside. This one actually might have been a DC to DC. I'm not sure. I can't really remember. But the point is, you know, if you go direct DC, you avoid that AC conversion, especially if you're already running off battery power as it is, because you're going from DC to AC back to DC, and you can avoid that whole conversion and save some efficiency maybe. Now, this thing I have gutted because I was thinking about doing the same exact project as I did with the Kobalt, where I could actually put like a little switch and a power switch, a voltmeter, a cigarette outlet, and some USB ports on here. Maybe you could put a flashlight, who knows. You can make your own little DC power station because you have this nice cradle here. It gives you access to your positive and negative ports. So it might be fun for a custom project next time. Well, that pretty much sums it up, guys. If you have any questions, comments, suggestions, whatever, please post them up. I appreciate that. I respond to all the comments. Have a good one.